So this exponential growth and decay really shouldn't be brand new to you either, but we're going to go back over some of it, even if it seems pretty basic, because it is an important thing to understand, and some of this that we talk about will be new. So when we talk about an exponential growth function, we can have exponential growth or exponential decay. As a function, this is going to be a function of time, so it's f of t. That's going to equal to your initial amount, which is a, times 1 plus the rate of growth as a decimal to the t power. If it's decay, that's also a function of time. I still have an initial amount, but it's 1 minus the rate. 1 minus the rate to the t power. So my guess would be the problems that you've done like this before, it's been a very basic plug and chug problem. They just give you everything and you throw it in there. It's still pretty much like that. I mean, you can't change these too much. You just have to pay attention to what t really is. T is time, but time in what? Years, months, days, hours, what is it? So this says, Brooke started her career with an annual salary of $64,000. So this is the initial amount. Each year, okay, so that tells me t is time in years. Her salary increased, so it's growth, 2.5%. Then it says write and use. Let's talk about what those two things mean. Exponential growth to find her salary when she retires after 30 years. So to write the function looks like this. F of t equals my initial amount, which is $64,000, times 1 plus, what would 2.5% be as a decimal? Is it 0.25? No. 0.025, yes, 0.025 to the t power. So that's me writing the function. Me using the function is substituting something in for t. So it says it's time in years, and we want 30 years, so t is just 30. That one's very simple. So f of 30 equals 64,000 times 1.025 to the 30th power. So we're going to need a calculator on this one. It's the first time we've actually needed one. You may have been using one, but you didn't need it. What kind of calculator you use, I don't care. If you have a separate one or you want to use your phone or whatever. But the one in Delta Math is nice because it handles your fractions nicely, which you may have one that does that as well. But when you're in Delta Math, if up here, like I'm not even on an assignment, and yours probably looks different than mine, but this calculator up here, if I just click that, it pops up down here, and then while you're in Delta Math, you can just use it there, all right? So we're going to type that stuff in. So it's 64,000, and then I open my parentheses, and I get 1.025, close my parentheses. To get my exponent, I do a to the b. They'll put it up there in the exponent for me. I didn't have this kind of trouble I'm having now when I was doing it on my computer. It's the board that's making it weird. But now I'm up in the exponent, and I can just type in my 30 right there. And then even before I hit enter, my answer is over here, but there's my answer. Okay. So that's just a good handy one to use. Sometimes the ones on your phone, unless you have the one that comes with the phone isn't always that user-friendly, but I know there's apps and other things out there. All right, so that means that her salary is $134,244.33. Pay attention to the questions in Delta Math when you get there, because some of them say things like to the nearest dollar, to the nearest whole number, or the nearest tenth. So make sure you're rounding to whatever it happens to say. None of these on here say, so if it's money, you always do it to the nearest cent. If it's people, you have to do it to the nearest person, right? And we'll talk about the other stuff. Everybody good so far? And this is pretty good so far, yes. All right, so then Kate drank an energy beverage with 150 milligrams. So 150 milligrams of caffeine, that's my initial amount. Each hour, so that means that T is the time in hours, the amount of caffeine in her system decreases, so it's going to be decay, by about 12%. So again, it says write and use an exponential decay in her system 1 day later. So F of t equals, my initial amount is 150 milligrams times 1 minus, because it's decay, 0.12 to the t power. So, is t, do I do f of 1 now? No, because the t is the time in hours, right? If it's 1 day later, what is t? 24. So watch things like that, because most likely that's where a mistake would happen, not just, typing things in. Then what's 1 minus 0.12? Thank you, yes, 0.88. Just 100 minus 12, basically, to the 24th power. All right, so go ahead and type that in to your Delta Math calculator. See what you get. I'll make sure I have everything marked off. It's 6.9 what? 7. Oh, I guess I should say this. You're going to round it. So if it doesn't say, which it doesn't say what to round to, then you'll, unless it's money or people or something, we always use 3 decimal places. Okay, that's the AP rule. That's what you're going to have to do on the AP test unless it says otherwise. So it's 977. Is that right? Milligrams. Be careful if I say that. So 24 hours later, she's still got some caffeine in her system. Think about that. If you drink a lot of those things. All right, now let's look at a half-life. I know these aren't new to you because people are usually like, oh, half-life when I say that. So we have the half-life of mercury 197 is 3 days. So that means T is the time in days. Okay? Write and use an exponential decay function to find the amount of mercury 197. That 197 has nothing to do with my problem. From a 50-gram sample after 20 days. So F of T, again, my initial amount is 50 grams. I'm going to multiply that times 1, this is decay, minus, what am I subtracting? What's my percent decay? Yes, 0.5, because it's half-life, right? 0.5. And then T is the time in days, but this doesn't happen every day. It happens every 3 days, so I have to have T divided by 3, because it's every 3rd day is that amount. All right, so then that means when I substitute this in, I'm going to have F of 20, because it's the time in days, and I have 20 days. So F of 20 is equal to 50 times 0.5 to the 20 over 3 power. And then we're going to type that one in because I like how it handles the fractions and stuff for you. So if I do 50 times 0.5, and then my exponent, oh no, I don't want my exponent there, see? I want that to go away. Okay, 0.5 to the, then I can do 20, maybe, I don't know why it doesn't like this, 20, maybe I need to stand in front of it. 20 divided by 3, there we go. But see, it'll make that into a fraction for you without you having to do anything weird. And even before you hit enter, your answer's over here. When you hit enter, it just gives you a new line. So that means we use 3 decimal places, so we get 0.492 grams. Any questions at all? All right. So let's talk about continuous growth and decay, which maybe is something that you haven't really looked at before. So it says, sometimes a quantity is constantly increasing or decreasing at an exponential rate, and not just after each year, month, day, hour, etc. So just think about like you're growing. You're not growing at an exponential rate necessarily, but even though you might just mark your height off once a year when you go for your physical or whatever, it's not like you grew that day, right? You grew over a period of time and it was like a continuous thing. You can't mark the time. That's what's happening with continuous. But the continuous growth and decay, anytime you see this word, it should make you think you're using E. This is where that E comes in. Right? And I'm going to show you a short little 2-minute video on that. In order to do that and everybody not have weird sound, I have to mute myself over here. Turn this off.
We've made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous, but equally fundamental number known to anyone who's taken high school algebra. It's about 2.718281828459045, and so on. And it was first defined by Jacob Bernoulli, but later Leonhard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So if you stick $1 into a bank account with a 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
Okay, so that's your basic explanation of E. Kind of like it's what we're approaching as we do an infinite continuous. It's not just every month, year, whatever. So this is where the Pert formula comes from, which may or may not be brand new to you depending on how far you got with that stuff last year. But A equals P, which is your principal amount or your initial amount, like it was for A on the front, times E, which is a number, just like pi, right, to the RT power. So if this is going to be a continuous growth, your R is positive. If it's a continuous decay, R is negative. Okay? All right, so let's talk about a garbage dumpster. So basically, it's not like you're only allowed to throw stuff in the dumpster like every 30 minutes. Only at 5, 5:30, 6, 6:30. Like it could be at any time, so it's a continuous growth. And it starts with 4 pounds of garbage. So we're going to have A equals our initial amount, which is 4, times E. The growth rate is 35%, so that's 0.35. And it says it's increased continuously by 35% each day. So that tells me my time is in days. So it says find the amount of garbage in the dumpster after 2 weeks. So what do I put in here for T? Do I put 2? I put 14 because it's 2 weeks. T is in days, so this has to be 14. So let me show you where to find this E on your Delta Math calculator. So I'm going to type in 4. Okay, and then I want the E, so my numbers are popping up right here. E, so to get there, you hit the functions. Still not there. Then you hit shift, and there's your E. Okay, and then I just hit shift to get back, and then I can get my exponent. So that's 4 times E to the 0.35. 5 times 14. And make sure all that stuff is up in that exponent. We now have 537 pounds of garbage. Right? So my answer is 537.159 pounds. So today, on today's assignment, you are going to have to turn in your work. I know you're using a calculator. I'm not expecting you to calculate this stuff by hand, but this would constitute your work. Like you have to actually write it down. The stuff we wrote down on the front page, that's your work. That's how you show work when you are doing most of it on the calculator, which is expected of you to do it on the calculator. Okay, it'll be the same on your AP test. Right? Okay, so now let's look at number 6. It says the population of a town is declining. Okay, so this is decay. At a continuous, that continuous tells me I'm using the E one, right? And then this is my rate, every 2 decades. So T is the time in decades. If the current population is 16,000, so that's my initial amount, I want to find the population in 8 years. Okay, so that's 8 years. I need to get it into decades. So how am I going to get the years into decades? Divide by 10. So I would do this 8 divided by 10, which I know is just 0.8, right? So A is equal to my principal amount, which is 16,000, times E. The rate is 0.259, but it's a decrease, so it's negative. Then I'm not multiplying by 0.8 because it says every 2 decades. So it's 0.8 of 8/10 of a decade, so I'm going to have to do that 0.8 divided by 2. Just like when it was every 3 days, we divided by 3. Every 2 decades, I divide by 2. So when you type it in, you could just do 0.4. That's fine, but that's where your numbers are coming from. Okay, so y'all go ahead and get that typed in. Make sure you can find E on that calculator or whatever calculator you're using. And once you get an answer, can you have part of a person? No. It's like when how many people can you fit on a bus? Like you can't put, 24.5 people on the bus. I think we should get 14,425 people. Do you agree with that? Any questions at this point? Okay, so the Pert formula you may or may not have seen before. Logistic growth, pretty confident you probably haven't. If you plan on going into business or taking business calculus, things like that, logistics are definitely something that would be something you need to focus on. Plus, you will look at these logistic growth functions in just regular calculus as well. But we talk about exponential growth, exponential decay, and we know it goes on to infinity. But not everything can go on to infinity. So let's say, we had a lot of students come back today, right? We're very excited to be Bianca's back. I wish the rest of you would come back. But let's say, not that this is what's happening, but let's just say that the number of students coming back is, back into my classroom is increasing exponentially. Okay, so if that was happening, because it could happen, but if that was happening, it's not going to go all the way to infinity. I'm not going to be able to fit an infinite number of students in this room, whether we're trying to social distance or not, right? There is some sort of limit to the amount of people that can actually be in this room and we can still function. So logistics looks at that limit, like having a horizontal asymptote here. So it says sometimes a quantity exponentially increases or decreasing. You can have logistic decay as well. Sometimes a quantity exponentially increases, but then levels out, approaching a horizontal asymptote. This is called logistic growth model. And so all we're really doing, this is truly going to be a plug and chug problem. We're not going to have to figure out anything. It gave us this, and it's going to give us the specifics for each problem, just so you're introduced to it and you know that it exists and why it would make sense, okay? So when we look at this first question, it says, a disease begins to spread in a town of 20,000 people. After T days, so T is the time in days, the number of people who have been infected by the disease is modeled by this function. So basically they just gave us everything already. Using the function, find the number of people infected after 10 days. So just thinking about this, could this number that we get be more than 20,000? There's only 20,000 people in the town. Would it make sense that 30,000 people got infected? No, not when you're talking about in that town. So that's why it's going to have to level out. It's not going to get to go to infinity. That's what makes it a logistic growth problem. So all we have to do here is literally substitute in that 10. So f of 10 equals 20,000 over 1 plus 1150 times e to the negative 0.95 times 20. So I just substituted that in. So when we go to put that in our calculator, that works out very nicely as well. So I'm going to have 20,000 And then when I hit divided by, I can just put everything else in the denominator. I don't have to do anything weird here. And I have 1 plus 1150 times E. So I hit function, shift E, shift back out of it. I need an exponent, e to the negative 0.95. Y'all probably typed it in a lot faster than I did because I have to go slow on this board. Times, was it 10? Yeah, 10. This also helps us with reasonableness of an answer because we know it can't be more than 20,000, right? And we can't have part of a person, so 18,414 days. Not days, people. 18,414 people. Now, this question, I've used this in the past. So I didn't just put this on there because of COVID, but that's kind of a scary disease. 10 days, almost the entire town is infected, right? They didn't even have enough time to figure out what was going on. It's like one of those movies or something. Right? Any questions at all? So again, I just wanted you to be exposed to logistic growth and know that not every exponential everything goes on to infinity. All right, we're not going to do number 8 because again, it's just a substitute in and it's fine. So remember, on your assignment is in Delta Math. You do have to turn in the work, so it's in there as an assignment where you can attach your work. And tomorrow you do not have school. You do not come at all. Teachers will be here, but you won't be. So. Anybody have any questions for me at all? Alrighty.